We're going to play around with the absolute value function here, just so you can start getting some intuition about how it looks. You probably remember that the graph of the absolute value function just looks like a big V. This is y equals x, right? The line on the perfect diagonal. The absolute value function is that function which takes whatever is inside the bars of the absolute value expression, and if the thing inside the bars happens to be negative, it turns it positive. And so this part of the line is safe under the absolute value effect because all the y values are already positive, but these are the ones that get affected because, for example, right here when x is negative 10, y is negative 10. When we put on the absolute values, that negative 10 is going to flip up to a positive 10. And so the absolute value function in its most basic form is a big V. And I'm sure you've, what the heck? There we go. And I'm sure you've seen it before. It looks like this. The rules about shifting and stretching and moving of this particular function behave the same as for any other function. So for example, if I just multiplied it out front by 2, that means every y value that's currently there gets doubled, which will make it a steeper, well, that didn't work, which will make it a steeper graph. If we make it negative, the whole thing flips over. If we add 1 to it, all the y values are increased by 1, and so the graph goes up by 1 unit. If we put a constant on the interior of the function, instead of just adding it to the outside, what that does is it translates the graph to the left or the right. So I'm about to put in a plus 2. So it will be the absolute value of x plus 2. Which way will that shift it? You might think, if I'm putting in plus 2, that means it's going to shift it to the positive direction, to the right. And that's actually the opposite of what will happen. So currently, we get the cusp of the absolute value when the input to the function is 0. The absolute value of 0 gives us 0 back. So if I change the interior of the absolute value from x to x plus 2, in order to see the vertex, I still need to be feeding a total of 2 into the absolute value, which means I need x to be negative 2 so that x plus 2 produces that 0 that I need to see. And so x plus 2 inside the absolute value shifts it to the left by 2 units. And then I can combine these things. If on the outside I do minus 3, that will drop the whole thing down by 3. If I multiply the front by 1/2, that will take what used to be all the old y values, or at least the values of absolute x plus 2, and cut them in half, which will mean that any particular x value now produces a smaller y value than it did before, and so that makes the graph a little bit less steep. So you start with the V, and then you do all your shenanigans to adjust the graph accordingly.